In this lesson, we're going to look at more applications involving trig, and we're going to still work with more than one triangle, but we're also going to come across a situation where we have to use more than one variable. We have more than one unknown. So let's look at this example. It says that there's two boats that are 75 meters apart, so go ahead and label the 75 meters, and that's going to be the distance from these 2 points that we're going to use, so from the center of the boats. The angle of depression from the lighthouse to the further ship, so angle of depression is measured from the horizontal line going downward to this further ship, is 30 degrees. So right away, the angle of depression is equal to the angle of elevation. If you look at the Z shape here, so this 30 degrees that touches the further boat is also going to be the angle of elevation from the horizontal line going to the top of the lighthouse from this further boat. So again, looking at the Z shape, that's how you can match that. And then if we look at the other angle to the closer ship, so again, measuring from the horizontal line down to that closer ship, so this entire thing here is 45 degrees. So that means, again, follow the Z shape, this angle down here is 45. You could also say, well, the closer boat to the lighthouse, the angle of elevation has to be equal to the angle of depression. So then the question asks us, how tall is a lighthouse? So we're trying to find this length right here. So I'm going to call that x for my height. That's what I'm trying to find, and that's going to be a right angle. Now the problem is x belongs to this small right triangle, and it also belongs to the big right triangle. It's one of the legs. But the only measurement I have on my triangle so far is the 75, and the 75 doesn't represent an entire side of one of these right triangles. The 75 represents the side of this obtuse triangle. So if we look at our two right triangles that we have, so I have this small right triangle, because remember with SOHCAHTOA you can only be working with right triangles, and I have this large right triangle. So I know that I'm going to be using this 75, but the 75 doesn't represent this entire leg. So instead, what I can do is say, if I call this pink leg here y, I know that this entire base is going to be y plus 75. I do know that much. But the problem is we have two unknowns. So that means if you have two variables and you're trying to solve for both variables, you have to have two equations. And then you're going to use a system to solve it. Two equations with two unknowns. And the reason, again, why I chose to label the bottom y and not like the hypotenuse for each of these is because the 75s are on the bottom. So that's going to help me kind of find the difference between the entire leg and the shorter leg. So if I actually go and set up an equation here, so if I look at the small right triangle, so let's look at the small triangle first. If I set up an equation that represents the 45 to the x and y, well, this is going to be the opposite side and the adjacent side. So that means we'd be using tan if we're thinking SOHCAHTOA, because we wouldn't be using the hypotenuse. So that means tan of 45 degrees is equal to x over y, the opposite over the adjacent. I can't solve that right now because I have two variables. So let's look at the purple triangle or the large triangle. So in the big triangle, again, the 30, this would be the opposite. So it'd be tan of 30 degrees is equal to the opposite over the adjacent. The adjacent is this entire bottom, the entire leg. So y plus 75. And again, I can't solve that because it has two unknowns. So what I'm going to do is I'm going to take these two equations and I'm going to get it so that I can plug one variable into the other. So if I take this first equation, this one's a little bit easier to work with because I don't have that y plus 75 on the bottom. And if I take this and I put it over 1, cross multiply, we get y times tan of 45 degrees equals x. So what I can do in this second equation is I can take and replace this x. So I can plug that into the second equation. And you can plug it in now, or you could cross multiply and then plug it in. Doesn't really make a difference. So let's just say I go ahead and rewrite this and plug in that x. So I'm going to replace x here. So it's going to be equals y times tan 45. And then on the bottom, I have y plus 75. So now what happens is I have this equation that has only y in it. It looks a little bit more complicated, but remember, tan of 45 and tan of 30 are just numbers. So this is just a proportion, really, that you're solving. So we're going to cross multiply. So we end up with y times tan of 45 degrees is equal to, and this is going to have to go in parentheses because it's a binomial, so it's going to be tan of 30 degrees times y plus 75. And what I need to do is distribute that tan of 30. Remember, tan of 30 is just a number. So it's going to be y times tan 45 equals y times tan of 30 plus 75 times tan 30. And instead of putting all those decimals in my calculator right now, I'm leaving those in terms of tan, so I don't have to write all the decimals. At this stage, though, you might want to take everything and make it a decimal, but you're going to have to keep the entire decimal. Otherwise, you can think of this as you got to combine like terms. So you have tan 45 of y, and you have tan 30 of them. So you're going to have to subtract tan 30y from both sides. I'm going to go ahead and make it decimals, though, just because I think it confuses people to think of tan 45 and tan 30 as numbers. So if we have tan 45, nicely, that equals 1. So that's just going to be, I'm just going to put 1 in front so you know that I didn't just drop the tan. So 1 times y. And then tan 30 is going to be this entire decimal here, 0.57735026919. Don't forget the y. So I basically just converted that. And then I'm going to have this entire decimal here, the 75 times tan 30. So that's going to give me the 43.3012701,892. Combine like terms, so that means you're going to be subtracting this number from both sides. So now you can see why I would have originally been subtracting, because I originally said you could just subtract y times tan 30 from both sides, but it's easier to see it when it's decimals, so that's why I say just convert it to decimal, even though it's more of a pain to write, but it makes more sense when you're looking at it. So I'm going to subtract y from both sides here, or that 0.577y. So I'm using 1 minus that entire decimal, 0.577. I end up with 0.42264973081. That's y is left with that because this is gone, equals this entire decimal here. And then go ahead and divide both sides. So divide, and I'm going to kind of cheat a little here and just put dot, 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 that I am dividing by that entire decimal. So that's okay to do that. Just make sure you put the dot, 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 so you're showing that you are dividing by the entire number in your calculator. So those are going to cancel. You're going to have y equals, so in the calculator I'm scrolling up to the 43 divided by the 0.4 number, and I get 102.45190524. That's the value of y, which is the total distance between the lighthouse and that closer boat. If we wanted to find the total distance from the bottom of the lighthouse to the further boat, we'd have to add 75 to it. But remember, I want the height, so I need to find x in my picture. So luckily, I already have this formula right here that has x already solved. So I'm going to go ahead and plug into that. So I'm just going to label this. This was step 1. Step 2 now is I'm going to plug into this formula. So I'm going to use this. So that means x is going to equal 102.45. Again, I'm just going to kind of cheat a little here, put dot, 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 times tan of 45. So I'm plugging that in. So in my calculator, using that entire value, times tan of 45. And we end up with 102, the exact same thing because tan of 45 is 1. So 102.451905284. And then from here, the directions tell us how tall is the lighthouse. So there's no rounding directions. Let's say round our answer to the nearest meter, so the nearest whole number. So the lighthouse is approximately 102 meters tall. And it just so happened that y and x are equal. This is like not something that would typically happen. It's just because tan of 45 degrees comes out to 1. So really we could have made this problem a little bit easier with just saying y equals x. But you need to know how to do the substitution. So that's why that wasn't the approach we took. We went right through and we worked it out how you would for any of these types of two variable problems. So whenever you have a situation where you have two variables, it means you need to come up with two equations and write both equations, get one equal to one of the variables, and then plug into the second equation and solve. And then either that answer will be your final answer, or you might need to plug back in to get the other variable, depending on the question. So get your key ideas written down and do your check your understanding problem.